Hey mechatronics students. In this video we're going to be talking about the Fanuc robot, and this unit is specifically about inputs and outputs. So in general, inputs are sensing things from the real world. The press of a button, a sensor, did it get triggered or not? Is there metal present or not? Is there like a reflective through beam sensor, a light curtain, the laser scanner? Those are all great examples of inputs. Outputs, on the other hand, turn things on and off. So we've got stack lights on the robot that are outputs. There's an alarm, a horn on the robot that turns on. That's an output. And other various indicator lights and whatnot. So the robot is typically used in conjunction with another controller, a PLC, and the inputs and outputs are being fed either directly from the robot to the PLC through hardwired connections, or they are done with a Ethernet and communications through digital means. So like a Modbus or a Modbus, CAN bus, Profinet, some sort of digital communication standards. So in this lab we're going to be talking about just the inputs and outputs on the robot, some of the different types, and so let's get into it. Alright, so for this purpose, I've got the teach pendant set up here, and let's say that we're on a different screen. So we can begin looking at this and saying, alright, where do we get to the inputs and what kind of varieties are there? So if you press the menu button, it brings up a list here, and we want to go to this section that's called I/O. So inputs and outputs. And we can hit enter. Now this one pulled up the analog input and output section, and that's fine, but we can change the type in here from one to another. So let's just work down here. I guess we'll start with digital inputs and outputs. So if we select that using the arrow keys and hit enter to select, then we can see a whole pile of different, in this case it's digital inputs that are listed. And let's see, in here, if I hold the shift key and then arrow up to the very beginning here, there are a pile of inputs that are available, and some of them have notes on them. So if I scroll down here, get into the 100 sections, we can see things like fence and T1, T2. So if I go to the front operator panel and move the switch from auto to T1, we can actually see the inputs toggling on and off there. So it's an example of an input being used. And then if I scroll down a little bit further, I can find some other inputs that are kind of interesting, specifically digital inputs 109 and 110 and 111. So those inputs are being used by the laser that's on the bottom of the robot that's going to basically be scanning the area to make sure that it's clear. So as I walk away from the robot, you can see that input is changing. So I'm physically walking away. Input 110 is the reset signal that's going on and off, and we can basically be triggering those inputs by our proximity to the robot. So that's kind of neat. And I think those are the only inputs of note there on the digital input side of this robot. Now if I hit the button for in out, I can change it. Now I'm looking at the digital output screens, and it's got a, let's see, I'm in section 100, so digital output 101 is listed as a laser. So that's kind of interesting. Down here there's an actual laser that is embedded into the jaws. It can be used for pointing purposes, I presume. So if I were to turn that digital input off, I can come over here to the laser and give it a on-off I'm trying to do it on my computer. That's funny. I need to use the teach pendant for this, and then go back to that particular output. Now, the laser, it's been turned off, and we can basically toggle that output on and off using that digital output. Very good. So back to the teach pendant. There's some other ones that are kind of interesting here. We've got the stack lights on the robot itself. It's got stack lights for indicating what's happening. So these stack lights are located at the top of the robot, and just for reference, I've highlighted them. And if I were to go to the green light and give that on and off, I can control each of these. The amber light on and off, and the red light on and off. So that's good stuff. Then there's a really fun one in here where I can go to the horn, and if I were to toggle the horn on and off, we'll be able to hear an audible beep here. So all right, so those are all good examples of digital outputs. And we could certainly add more of them if we were to connect to a PLC, and perhaps we could give an external signal to start a program, or an external signal that says maybe you need to stop, or that the program has been finished as a output from the robot. So between the digital inputs and outputs, it's a real simple way that we could communicate, and we could set up a hardwired connection between the robot and the PLC and send inputs and outputs, signals back and forth, telling it to start and stop, and whatever we need to have happen there. So if we needed to connect a conveyor belt or other things to the robot, that would be a good way to do it. So that's one type of input and output signal, the digital type that's defined in here. But if we go to the type variety here, another one that is worth mentioning here, I'm going to go way down here to the standard operating panel type. And these are standard outputs that can be used, like the cycle start button. We could turn that on. That's the green light on the front of the control panel. We could run that. The teach pendant enabled. If I were to toggle the teach pendant on and off, we can see the teach pendant on-off switch is being toggled on here. And if I change the variety to output, we can see things like, input, digital input. The cycle start button, if I were to push the green cycle start button on the front of the control panel, that's right there for you as well. These particular inputs are useful for troubleshooting purposes. So if you were to, wow, why isn't the start signal operating? Why can't it go into from auto to teach mode? By looking at these menus, you can see, is that input actually functioning? I don't know if there was anything of note here in the user panel variety. Yeah, teach pendant enable, battery alarm. So again, just a couple of different variety of inputs and outputs that are used by the system or the user panel for the robot. That's good. The other type of input I wanted to make sure we talked about in this video is the robot's input and output. So I'm going to make a distinction here. The controller has its own digital inputs and outputs. So those are the ones we went through, and the controller outputs would be like those indicator lights over there. Or a controller input would be the laser scanner that's at the bottom that's telling us if we're getting too close to the machine or not. So those are good examples of the controller's inputs and outputs. And we can also interface other inputs and outputs with it. We can get into there and connect inputs and outputs hardwired to other control devices and have them talk to the robot. So those are all the digital ones. Now, when you're talking about the robot inputs and outputs, This robot has a bunch of outputs, basically some solenoid valves that are built into the robot itself. And those are connected to the gripper, and they're hardwired into it and controlled. There's a connector in the back of the robot that has all of those digital outputs. So a robot output is the gripper. A robot input, there's a connector up here that's covered with a dust cap, and it's got a number of pins on that. We could connect a number of those pins to different sensors on the end of the tooling for the robot. So as an example, if the gripper closed and a sensor was made telling us that it is closed, we could feed that information back, and that would become a robot input. So the robot inputs and outputs are things that are physically wired up to the robot themselves, and then there's a connection that goes from the robot to the controller. So let's take a look at the robot inputs and outputs. So this is an example of robot outputs. So if we use our cursor to scroll up here, we can use the gripper on off. So that's looking good. On the robot themselves, you can hear a little psh, 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 as they're opening and closing. And then robot inputs, in this case it's completely blank. None of the robot inputs have been defined at this time, so we're just going to leave it alone. But definitely robot outputs are a useful thing. So now let's call them up and use some of these inside of a program. So I'm just going to edit an existing program. So go to select, and I'll find one that's probably like the mech demo, something like that would be perfect. Okay. So we've used this program in the past to just demonstrate some of the basic things, and I'm going to go ahead and insert a blank line here. So I've always got to think about how to do this. So hit the edit command, insert, and I'm going to insert one blank line and enter. So at this point I'm going to add a robot output instruction, because that's one of the more useful. Actually, this is the beginning of the frame, so maybe I'll use that horn, because that was kind of a obnoxious thing to do. So we can add an instruction, and this is going to be an I/O type, input-output type. And from there, well, what type is it going to be? The horn, I had this written down somewhere, was digital output 105. So I'm going to choose DO, and I'm going to enter the number 105, enter, and I can turn it on and off. So I'm going to turn it on. That's fantastic. Then I'm going to add another line. So at the beginning of my program, let's see, I'm going to add 2 lines this time around. I'm going to offer up a wait instruction. So I'm going to fire up this horn for a couple of seconds and then go into the rest of the program. So we're going to go ahead and add an instruction for a wait for a number of seconds, and let's go 2. Enter. So turn the horn on, wait 2 seconds, and then we're going to add another instruction, again an input-output variety, and we're going to go with a digital output 105, enter, and we're going to turn that to its off state. Fantastic. So I'd like to give it a go here. So we're going to run the program starting at the very beginning of the code, and we'll step through, waiting 5 seconds for some good reason. There we go. So it did its job. It beeped at me for 2 seconds before it went on to run its code. So that's a great example of using a robot digital output for some purpose. Okay, so that's very good. Now, if we wanted to use the gripper to get in there and do something, we would add that. So perhaps after instruction number 1, I'm going to put it in step mode at this time and step through getting it to point number 1. Okay, there's point number 1. So maybe that's a picking point where at that point I'm happy, it's right on top of something, I need to close the jaws. So I'm going to put in a new instruction, or some insert lines here, my bad. Flying around. Insert a couple of blank lines, probably only needed 1, but we're going to add an instruction here to close the gripper. So that would be an F1 instruction, an IO, but this time it's a robot output, an RO. So in this case, I forgot what it was. So I'm going to actually have to go back and look at what number that robot output was. So robot outputs, there we go. The gripper itself was RO3, robot output number 3. So now we'll go back into our program, now that I've recalled what it is, and it's robot output 3, enter, and I can have the option of turning that on or off. And sometimes it's interesting that you've told the jaws to close, but there's a small delay. So I've seen it happen before where the robot jaws will open and close, and then it didn't actually grab the object. So it's important sometimes with pneumatics especially that if you wrote this program to have the jaws, give them a little bit of time to actually close and clamp down on the object that you're trying to grab. So it's important that we add a little bit of a wait, even if it's just a pause for a second for the pneumatics to close up, and then we can move on to the next section in the program. And the same thing goes for when we release something. You may fire off the grippers to open up, but give them a little bit of time, depending on what you're talking about, for pneumatics to physically open before you advance to the next section. So let's continue on with the writing of this program. And so we've opened, or we should have closed the gripper at this point, and I said we were going to add a wait instruction. All right, so we're going to add a wait for another number of seconds. Wait for 1 second, enter. Okay, close the gripper, wait just a little bit. Let's say that we were going to the position register. That's fine. We'll go ahead and run that instruction. Right above there, I'll insert a new command. Insert 1 blank line. Oh, you know what? We're going to make that 2. Okay. And what we're going to do at this point is turn the gripper off. So, again, it's an instruction for I/O. Robot output variety, number 3. Enter. And we're going to turn it off. Then I'm going to have a wait instruction afterwards for 1 second before it does the next thing. Okay, so that should be good. At this point, let's take a look at what happens in the program. Okay, so the robot's there, ready to go. Now I'm going to go ahead and fire this up, probably run it in a step mode initially, see how it goes. So we're stepping through, waiting 5 seconds. Setting up the user frames. At this point, we're going to hear the alarm. It went for a little bit longer because I'm in step mode. It just left that on for a longer duration. So we're at that point, and it should have turned on the gripper. Oh, it looks like I may have on and off reversed on these. It could just be a couple of pneumatic hoses, but I'm just going to keep going. Just stepping through the program one line at a time, and we should see then the gripper do the opposite behavior once we get down to the end of the program. So it should go to position register number 1, and then the next thing it should do is, there it goes, it snaps that gripper, and that didn't show up real well on the video, but I did hear a psh, psh. So it is functioning. And if we go back to the beginning, there's our alarm again. And we'll just show you in the program. It's going to get to point number 1. After point number 1, the gripper should open, waits for 1 second of duration, and then we progress through the next lines of code. Nothing really remarkable there. Okay, so now that it's done that, at this point, the next instruction is to turn off that robot output. So there we go. We've made it through a bunch of different types of robot inputs and outputs, and in the lab, you guys are going to be writing some programs that are going to be turning on and off the grippers and utilizing some of the lights that are over here. And the horn, so you'll be using some of the robot's inputs and outputs. So we'll catch you next time.